Hello everyone, my name is Alay Patel and my student roll number is PCM 23002 and I am a student at SEPT University. My portfolio reflects my studio work on building information modeling, that is BIM, focusing on three main areas: level of development (LOD), level of scheduling (LOS), and LPS in design and integrated collaborative planning versus traditional approach. We have selected a mixed-use project located at Satellite, Ahmedabad, Gujarat. The development includes three basements, a ground floor, a first floor dedicated to commercial shops, and residential apartments from the second to 17th floor. The project spans a total built-up area of 5 lakh square feet with an estimated cost of rupees 350 crore. The construction commenced in January 2023 and is expected to be completed by 2026. Coming towards my roles and responsibility, so as a structural and mechanical consultant, my roles and responsibilities are referring to and ensuring adherence to all structural drawings, preparing the LOD 400 structural model and LOD 300 mechanical model, resolving RFIs and addressing clash detections, and ensuring the accurate referencing and coordination of structural 2D drawings. Coming towards the scope of our modeling, it encompasses all three basements, the ground and first floors, which is commercial, and the second floor, which serve as a transition covering both commercial and residential areas. Additionally, the scope for the LPS includes the 15th, 16th, and 17th floor, and the accurate project location is situated near the Prenatix Derasar Road in Satellite. So, in the development of different levels of detail (LOD) models for this project, we focused on progressively refining the model which we have shown. LOD 100, that stage involved creating a basic mass model to represent the building's overall volume and layout. LOD 200, at this level we introduced preliminary attributes such as wall types, materials, and other essential components to provide a general understanding of the structure. LOD 300, the model became more detailed, incorporating elements like seals, lintel heights, glazing finishes, and railing details. This ensured clarity for on-site construction and alignment with project specification. And LOD 400, this is advanced level. The model focus on fabrication ready components, including precise dimensions, specification, and details required for accurate construction execution. Below shown his plumbing model, a detailed LOD 300 was developed. It includes pipe connection to floor drains and fixtures, providing a comprehensive view of the plumbing system and its integration with the structure. Next to it is the electrical model was also developed at LOD 300. It featured detailed representation of electrical conduits, junction boxes, and electrical equipment to ensure seamless installation and coordination. By working across these LOD stages, we ensured that the project models were not only precise but also practical for each phase of construction, addressing potential issues early and streamlining execution. For this project, we meticulously prepared an MSP schedule that is closely aligned with the studio timeline. This schedule served as the foundation for organization activities and ensuring proper sequencing. From the MSP schedule, we developed a detailed activity table outlining the specific tasks that are planned for each week, including the responsible personnel or team designated as the model elemental authorities for each activity, that who will be the author of the activity, who will be the responsible person for that activity. We have developed that in a whole detailed manner. This approach ensured accountability and streamlined workflow throughout the process. The activity table covered 6 weeks of the project, providing a clear breakdown of scheduled tasks and their prospective authors. For instance, during week 2, the key activities include preparing grid labels and coordinates with architecture templates, ensuring the integration of these elements into the model, assigning the author is architecture as the responsible authority for these activities is architecture only, and the glass doors on the right side, the glass doors were modeled with precise lintel heights and associated railing details to ensure alignment with design and construction requirements. Lintel and glass railings. Special attention was given to developing accurate representation of lintels and glass railings. This is not only added to the clarity of the design but also facilitated smooth execution during the construction phase. The accompanying images demonstrate the high level of detail achieved in the modeling process, highlighting elements like glass doors, lintels, and railings. Benefits of our approach is alignment with timeline, clear responsibility, defining model, elemental authority, providing clarity on ownership of each task, the focus on elements such as glass door lintels underscored our commitments to the accuracy, seamless coordination that could breakdown of activity helped address the potential challenges, ensuring the project that stayed on the track. This structured approach and detailed modeling not only enhanced the project's quality but also ensured a smooth workflow from the design phase to the execution phase. In week 11, the table shown the project schedule that was highlighted during the development of LOD 400 reinforcement details for the concrete pours in week 11. These detailed reinforcement models provided an in-depth view of the structural elements, enabling precise identification of tasks scheduled for specific weeks or days. Furthermore, it clearly delineated the responsibilities, specifying who would be accountable for each activity's completion. This level of detail ensured seamless coordination among teams and minimized the potential delays. Highlighting activities of week 11, LOD 400 reinforcement detail models were developed to fabrication ready precision, showcase, showcasing critical elements such as reinforcement layouts for projected beams, ramps for each floor, projected sunken slabs. Show the timeline for pouring, reinforcing, and detail of each element. Designation of responsible personnel or teams for the execution is structural engineers were identified as the primary authors for the reinforcement details, while on-site the construction teams were tasked with the implementation. The development of LOD 400 model was perfectly aligned with the MSP schedules as providing insights into each task that would occur during the week or the day, dependency between activities, ensuring task that were completed in the sequence with overlaps or delays. On the right side, the picture is shown that we have done that projected beam details, ramp on ground floor, projected beam and sunken slab. Coming towards the last planner system design, the LPS design, we created an MSP schedule that was meticulously tracked on a weekly basis by breaking down activities and identifying the specific days on which they were scheduled. The systematic tracking allowed us to monitor the progress of each activity and assess whether it was completed on time or not. In our activity table, if an activity was completed as planned, it was marked with a 1. If it is incomplete, it was marked with a 0. For incomplete activities, we also document what are the constraints that were preventing for the activity completion. For instance, the development of the ramp scheduled for 30, 37 was delayed due to the unavailability of 2D drawings. This method ensured transparency in tracking and facilitated quick resolution for identified issues. We also compared planned activities with actual progress to evaluate performance. A weekly PPC table, planned percentage complete table, was prepared showing the percentage of activities completed as per the planned schedules. For example, in week 1, there were 8 planned activities. However, one activity was not completed due to the constraint, resulting in weekly PPC of 88.89%. Similar calculations were carried out for subsequent weeks to measure performance and track improvements. During the We have also tracked the observation and trends for each week. During the first 3 weeks, several constraints were identified and documented, such as missing resources or unavailability of drawings. By addressing these constraints, the project achieved a better alignment between planned and actual activities during the last 3 weeks, showing a significant improvement in execution efficiency. It achieved 100% result of planned versus actual. A graph of weekly PPC was developed to provide a clear visual representation of progress over time. So the initial lag in the first 3 weeks due to constraint, steady alignments in the final 3 weeks as constraint was resolved with planned and actual activities. We have another table of MSP in week 3, a weekly basis breaking down activities and identifying the specific days that they were scheduled. In week 3, the consultant responsible for the activities was the structural consultant. While all activities for week 3 were marked as completed, two major constraints were identified during this period. The RAM could not be accurately modeled in Revit because the necessary 2D drawings were not provided by the structural consultant, the resulting in delays in refining the model to meet design requirements. And the 2D drawings provided lacked proper detailing for the staircase. This led to mismatches in levels between the staircase and the ground floor shop, requiring additional revisions to ensure alignments. These constraints were highlighted critical gaps in coordination and documentation that affected the efficiency of the modeling process. By identifying and addressing these issues early, steps were taken to improve collaboration and ensure more accurate and detailed inputs in subsequent weeks. These two are the major in unavailability of ramp 2D drawings and not matching with the labels in 2D drawings. So these were the constraints identified and resolved in the later stage. The table not only captured the progress of scheduled activities but also provided a clear understanding of the challenges faced, enabling proactive measures to avoid similar issues that could be impacted to the project. We have included several graphs to provide a visual representation of project's progress and performance. The first graph illustrates the weekly plan percentage complete. It highlights the performance across different weeks. Week 1, 3, and 4 achieved 100% PPC, indicating that all planned activities for these weeks were successfully completed on time. The remaining week showed minor deviation, reflecting challenges that were addressed promptly to minimize their impact to on overall progress. The right side bottom graph depicts the percentage plan complete over time. This graph showcases the alignment of actual progress with the plan schedule, emphasizing consistent efforts to meet project goals. While there are some deviation from the initial plan, the majority of critical tasks were successfully completed within the time frame, and the graph clearly illustrates the significant accomplished throughout the week. And this reflects a strong adherence that are complying with the studio timelines and deadlines for an effective project management strategies. Coming towards the comparison of ICP with the traditional approach. So first we will compare conventional approach with the ICP approach for EIR and BEP. I have identified lack of clear goals, undefined roles and responsibilities, and manual processes. Comparison to the ICP approach, it gets clear expectation and responsibilities, standardization and documentation that helps in the manual smooth process, common data environment that helps to the consultants that all consultants will work under one roof, and assess the risk that will severely impact the project, and following all the quality measures and management. Coming towards the LOD versus LOS, its traditional approach is to defining the progress levels according to the LOD requirements, then outlines each stakeholder's work goals as per the week, and keep all team members on track with project objectives. ICP approach for LOD versus LOS is lack of clear milestones defined. There were no standard development levels and unclear responsibilities. Coming towards the 3D modeling, the traditional approach for 3D modeling would be it is relied on 2D drawings, making it harder and visualize the design. It there is a chance of increased error and inconsistency due to the manual process, as ICP approach provides the 3D views that could be the realistic for the design, centralized model that allowed all the stakeholders to work under one roof. For example, our project includes sleeves that have been placed accurately and can be coordinated with structure and firefighting consultant. But in the traditional approach, these sleeves have been incorrectly shown in the drawing, and it increased the rework at the site. Coming towards the site layout optimization, for the conventional approach, it is hard to visualize the layout and optimize the space. There should be high chance of the risk and unorganized zones. With comparison to the ICP approach, it should be better in visualization, enhancing the site planning, and reduce the on-site conflicts. Coming towards the clash detection and coordination and resolution. For the conventional, it is inefficient problem solving, increased risk of errors, and rework, change orders, and delays increase project cost. An ICP approach visualize and identify spatial issues before construction, modify designs or sequencing to fix clashes, and reduce reworks and delays. Coming towards the quantity takeoff. Its conventional method is that it should be relied on 2D drawings, making it harder. For example, in AutoCAD, there were no elevation for plumbing services. Similar to the ICP approach, Revit generates accurate quantities directly from the model. Design changes, it would be directly automatically updated to the quantities. It is time saving and cost saving also. Coming towards the 4D simulation, its conventional approach is it is difficult in coordinating tasks without visualizing any construction flow or potential delays. Its ICP approach is that it helps stakeholders to visualize the delays. Example, we have taken staircase as a BIM use case. Coming towards the 5D simulation, costs are estimated manually. Cost overruns are harder than it should be predicted. Its ICP approach is the tracking of actual costs against the budget for changes in scope or design. The last planner system conventional approach is that the tasks are monitored weekly, making it harder to stay on the schedule. Constraints are materials material strike, unavailability of the drawing. ICP approaches, tasks are planned and tracked weekly, ensuring on-time completion, identifying the constraints and resolving it on the later stage so that the later stage doesn't get any constraint. So key learnings from the last planner system is throughout the integration of LPS, the project team achieved more efficient workflows, better communication, and higher accountability. It focuses on identifying and resolving constraints from variance through continuous improvement that ensuring the project remained on track and met its goals effectively. LOD versus LOS. From that, we learned that the element authorization table that specifically disciplines the responsible author for modeling project components, clearly defining their responsibilities and roles. The LOD versus LOS chart visually represent element modeling against the development levels that should be aiding in project scheduling. From the ICP versus traditional approach, we learned that BIM approach typically results in disjointed workflows that is inefficient due to isolated teams and a lack of real-time collaboration. On the other hand, the ICP approach that is smoothly collaborated, bringing all stakeholders together under one roof, improving the communication gaps and minimizing errors that could be enhancing the project outcomes. Thank you.